Topic is suitable representations to illustrate system requirements. So first off, we have the three types of processing. We have online processing or interactive processing, real-time processing, and batch processing. So online processing is processing that's done in as the data comes through. So for instance, making an airplane reservation or making a cinema reservation, as you can't double book these things because then you'll have serious issues. Real-time processing is data processing that's performed on the fly as data is created. So for instance, aircraft controlling a car, because many of these things have electronic systems in them these days. And then batch processing is when the data is processed in large groups. So for instance, when processing a payroll, you wouldn't want to have a system that's constantly running to process the payroll because it's just inefficient. So many companies at the end of a month, they'll have one system that runs all the payrolls, does all the payroll in one evening or a couple of days. Okay, now we come on to system flowcharts. So these are used to show the flow of data in a data processing system. It can show each of the types of processing that I just talked about above, and it only refers to the hardware in a system. So as you can see on the left, we've got some of the different icons or symbols that you can use. So you've got a square and kind of a tilted over square, which is action and process and input and output. Then you've got your data flow, and then you've got your document, your tape, disk, and your online storage. The online storage one is a little bit of a weird symbol. So this is an example of a system flowchart. So this is to handle system employee payments. So this is a bad way of doing it, but the employee inputs the number of hours they've done. It checks the hours against whatever system they've got. Then if there's an issue, it reports the error. Otherwise, it puts it to the transaction file, then it calculates it. And then from the calculator, it goes to print slips and prints out the slip for each employee, as well as transferring the details to magnetic tape and backing it up to the cloud. So now we come on to data flow diagram. So these show how data moves through a system and how the system uses the data. The type of data storage doesn't really matter. So it's got these 5 symbols, although the data store I wasn't sure which is which. There's also one with the thick line. So you've got process or calculate. We've got external utility, and we've got data store, data flow, and the sync, which is kind of a bigger process. So for instance, a processing of a database. And then this is an example of a data flow diagram. So this is to check for a driver's license. So the driver inputs their details, and then it checks it against these two storage things. So it's got the age, it checks their age, and it checks their medical examination. And if both of these are correct, then then it outputs the result depending on what it sees.
Can you just go back a sec, Andrew?
Yeah, sure.
I forgot to mention go forward.
Yeah.
The main difference with this one is that with the DFD, you see each of the arrows have a label. You don't have that on flowcharts. Okay. You have to have labels on DFDs to represent what all the information is passing to and from each process. Thanks.
Okay, now we come to a structure chart. It's used to show the relationships between functions and subfunctions. It splits your problem into modules, so it's very much like programming where you've got your different modules in your methods. So this is a structure chart on the left of building a house. So it shows all the sub-processes that have to be done to build a house. So you've got to do the concrete, the framing, the plumbing, the electrical. So it just breaks it all down into these sub-functions or these sub-things that you've got to do to complete the overall task. It's much easier to complete tasks when it's broken down into modular little small bits. Okay, now we've got modularity and types of modular design. So there's two ways of doing modular design. There's top-down, which is breaking it down into sub-functions, and then after breaking it down, you break those sub-functions into sub-functions again. All problems, it's breaking the problem down into smaller pieces, so they're easier to handle. And then you can also do it in pseudocode, which you've all used. It's English-like language for representing code. It's much more like high-level language. And then we have modularity. So a module is an independent part of a program. Modular programming is the method of breaking down a program into subprograms or subproblems. And a modular language is a coding language that supports modular programming, such as Java or Python.